Hi everyone, in this video we are going to discuss the topic locus of a point. So what is the locus of a point? When a point moves in a plane according to some given conditions, the path along which it moves is called the locus. That is, we will be given some condition and based on that condition a point moves in a plane. The path along which that point moves is called the locus of that point. I will give you an example. Suppose this condition is given. That is, a point P moves such that it is always m units from the point Q. So here Q is the fixed point and the P is the moving point. And there is a condition given here. The distance between P and Q must always be m units. So wherever the P moves, the distance between P and Q is a constant, that is the m units. So how can we find the path here? Because the locus of the point is the path along which the point moves. So here we need to find the path along which the point P moves, and it satisfies the condition that the distance between P and Q will always be m units. So how can we find that path? So here I am taking a fixed point, that is Q here, and we know that the distance between the moving point P and Q is always m unit. So I am taking an m unit here. This length, let this length be m unit, then the end point will be P. This is our P and this is m unit. This distance is the m unit. So this is our point P and this is our point Q. So now P is the moving point. So if the point P moves to here, the distance between P and Q must always be m unit. So this distance, that is, if I move the point P here, then this distance will also be m unit. That is, here this distance is also m unit, and if the point P moves here, then the distance between this point and Q will always be the m unit. So here also the distance between P and Q must always be m unit. So if we move the point in a circular manner, that is like this, if we move the point in a circular manner, then we already took the distance between P and Q here is m unit. So if we move this point P in a circular way, then the distance between Q and that moving point will always be m units, because in a circle the radius of the circle is a constant. So here this is the radius of the circle, Q is the center and this m unit is the radius. So if we take any point on this circular path, then the distance between that moving point and the Q will always be m unit. Here m is the radius. So we will get a figure like this. This is the circular region, Q is the center. This point here, this is the path along which the point P moves, such that the distance between the moving point and Q will always be m unit. So here we know that the locus of a point is the path along which that point moves, satisfying the given condition. So here the path here is this circle, because if we take any point on this circle, the distance between Q and that point will always be m unit, because m is the radius of this circle. So the locus here is this path, this circular path. So this is the path taken by the moving point P. Therefore, this is the locus of the point. So here the locus formed is a circle with a center Q and radius m. Now, suppose the condition 2 is given. A point P moves such that it is equidistant. Sorry, here this is not from, this is from two fixed points x and y. So here the given condition is x and y are two fixed points and the point P moves, and the distance between P and X must be equal to the distance between P and Y. That is what is meant by equidistance. That is, the distance between P and X must be equal to the distance between P and Y. So we have to find the path along which the point P moves, which also satisfies this condition here. So first write the fixed point, that is here X and Y are the fixed point. So I am writing, this is our X and this is our Y, and the point P is equidistant from the 2 points X and Y. So if we draw a line segment from X to Y, line segment from X to Y, then the distance between, then if we take the midpoint of this line segment, that is, let it be P. So this is the midpoint and let this point be P. So if we take P as the midpoint of the line segment joining X and Y, then this length, that is Px and Py, will be equal. Here Px equal to Py. Since P is the midpoint, it divides the line segment. This point P is the midpoint, so the point P divides the line segment into 2 equal parts. So Px and Py will be equal. So this point P satisfies the given condition here. Now we have to move this point. So if we take P here, let this point be our new P. So I am naming it as some P dash. So what will be this distance? What about P dash X? That is, here P moves to P dash. Then what will be P dash X and P dash Y? Now what will be here? This will be 90 degree because this is a perpendicular line. So this will be 90 degree. So we have to check whether P dash X and P dash Y will be equal. So this is a right angled triangle. Now we know the right angled triangle Pythagoras theorem, that is P dash X whole square is equal to Px square plus P dash square, that is hypotenuse square equal to base square plus altitude square. This is the result we used here, base square plus altitude square. So we know Px and Py are equal, so we can write here as Py whole square plus P dash whole square. Here Py is this part and P dash is this part. So Py square plus P dash square will be equal to P dash Y square because this is also right angle. So this will be equal to P dash Y square. Now P dash X and P dash Y are distance. You know, distance between 2 points P dash X and P dash Y. So it will never be negative. So taking the square root, we get P dash X will be equal to P dash Y. So if the point P moves to here, the distance between that point and X will be equal to the distance between that point and Y. So this point here and here satisfies the given condition. Now we move the point P from P dash to some other point P double dash. That is, I am taking this point as P double dash. So if we join X and P double dash and P double dash and Y, and I am joining this also, then consider the triangle PXP double dash, that is this bigger triangle, you know, this bigger triangle here. Then in similar way we can find P double dash X whole square, that's equal to PX whole square plus P double dash whole square, because this is our hypotenuse because 90 degree is here. So P double dash x square will be equal to Px square plus P double dash square. Now we know Px and Py are equal. So we can write Py whole square plus P double dash whole square. Now what will be this? Py square means this part. Py square plus P double dash square means this part. So this will be equal to P double dash y whole square. So now P double dash x and P double dash y are distant. So taking the square root we get P double dash x equal to P double dash y. So this length and this length will be equal. Similarly this length and this length is also equal. So if we move the point P along this line, the distance between that moving point and x will be equal to the distance between that moving point and y. So we can move the point P along this perpendicular line. So similarly if we take the point P below also, that is here, here, anywhere, then also the distance between that moving point and x and y will be the same. So here the point P moves along this yellow line, because if we take any point on this yellow line, that point and x will have the distance equal to that point and y. So here the path along which the point P moves is this yellow line, which is a perpendicular line drawn through the midpoint. So if a perpendicular line divides the line segment into two equal parts, then that perpendicular line is called perpendicular bisector. So this yellow line is the perpendicular bisector of the line segment xy. So here the point P moves along this yellow line. So here the path along which the point P moves is the perpendicular bisector of the line segment xy. So the locus formed here is a perpendicular bisector of the line xy. So in the above two conditions, we found the locus in a graphical way. That is, we used the graphical method. We draw the picture and found the locus of the point. So in the next problem, we will find the locus in another way. That is through simplification. Here we have to find the locus of a point whose distance from the point 1, 2 is equal to its distance from the axis of y. So here the moving point whose distance from the point 1 to is the fixed point. So the distance between the moving point P and the fixed point 1, 2 must be equal to the distance between the moving point and the y-axis. So the distance between, let P be the moving point. So distance between P and 1, 2 must be equal to distance between P and y-axis. So this is the condition given here. We have to find the path along which this point P moves satisfying this condition. So here let P be the point xy. So P be the point x comma y. So then what will be the distance between P and 1, 2? We can use the distance formula. That is, if 2 points x1, y1, let this be A, and x2, y2, let this be B, is given, the distance between A and B is denoted by AB, which is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is our distance formula. So using this formula here, P is the point xy. So P is the point xy and our second point is 1, 2. So use this formula here. So distance between P and 1, 2 will be equal to root of P is the point xy and this is 1, 2. 1 minus x whole square plus 2 minus y whole square. This is the distance between P and 1, 2. This is equal to distance between P and y axis. So what if we draw, this is our x axis and this is our y axis. Let this point be our P, that is P is the point xy. So since the x coordinate of P is x, we draw a straight line here. This distance will be x unit, and if we draw a perpendicular to y axis from P, and this distance will be, and this distance will be y, because this is our y point, because the y coordinate is y here, so this is our y point and this is our x point and this is the origin. So this is our x point and this is the origin. So 0 to x the distance will be x, and from 0 to y the distance here will be y. So this length will be y, this distance here will be y, this distance here will be y, so this length will be y, and this is our x length, so this length will be x. So the distance of the point P from y axis will be equal to x. That x is the x coordinate of P, so this distance is equal to x. The distance from P to y axis is x. So this is our x. So squaring on both sides we get 1 minus x whole square plus 2 minus y whole square is equal to x square. Now here if we expand the expression, this is a minus b whole square form, a square minus 2ab plus b square. So 1 minus 2x plus x square plus 4 minus 4y plus y square is equal to x square. So here there is x square and here there is x square, cancel on both sides. So we get y square minus 4y minus 2x plus 5 equal to 0. So this is the equation of the locus. The locus of the point satisfies this equation. So this is the locus of the point which satisfies the given condition. The next problem is, find the locus of a point which moves such that the difference of its distance from the points 3, 0 and minus 3, 0 is 4 unit. So here let P of xy be the moving point and let A be the point 3, 0 and B be the point minus 3, 0. It is given that the difference of its distance from the points 3, 0 and minus 3, 0 is 4 units. So here the distance, first we find the distance between P and the point A, then the distance between P and the point B, then the difference of this distance will be equal to 4 unit. This is the given condition. So we have to find the locus of P which satisfies this condition. So we will find PB and PA and substitute this in this equation and then we simplify. So here to find PB we will use the distance formula. So here P is the point xy and B is the point minus 3, 0. So when we use the distance formula, we get x plus x minus minus 3. Therefore x plus 3 whole square plus y minus 0 whole square minus PA will be x minus 3 whole square plus y minus 0 whole square. This is equal to 4. This implies root of x plus 3 whole square plus y square minus root of x minus 3 whole square plus y square, that's equal to 4. Now we have to remove the square root here. So take this term to the right side of the equation. Root of x plus 3 whole square plus y square is equal to 4 plus root of x minus 3 whole square plus y square. Take square on both sides. When we take squaring on both sides, we get this root will be removed. So x plus 3 whole square plus y square will be equal to 4 plus root of x minus 3 whole square plus y square whole square. So when we simplify here, we get this is a plus b whole square form, x square plus 6x plus 9 plus y square is equal to, this is a plus b whole square form, a square plus 8 root x minus 3 whole square plus y square plus x minus 3 whole square plus y square. Here a plus b whole square is equal to a square plus 2ab plus b square. So now when we further simplify this equation, we get here x minus 3 whole square is x square minus 6x plus 9. Now we have x square on both sides, so it will get cancelled, and 6x equal to minus 6x means it will be 12x. And here there is 9, here there is also 9, it will get cancelled, y square will get cancelled. So we will get 12x minus 16 is equal to, here there is 16, so I take it on the left side. So remaining will be 8 root x minus 3 whole square plus y square. So here the root is along here, square root is along here, so we can square on both sides in order to remove the square root. We can take 4 outside here, and this 4 and 8 will get cancelled, and remaining it will be 2. So here 3x minus 4 is equal to 2 root x square plus y square minus 6x plus 9. Now take square on both sides, we get 3x minus 4 whole square is equal to 4 into x square plus y square minus 6x plus 9. We can use a minus b whole square here, and when we simplify, we get 5x square minus 4y square is equal to 20. So here 20 can be divided by both 5 and by 4. So 20 is a multiple of both 5 and 4. So we can divide here throughout by 20. So we get 5x square by 20 minus 4y square by 20 is equal to 1. Here there is only x square and y square term. So check whether the constant is a multiple of both the coefficient of x square and y square. If it is a multiple of the coefficient of x square and y square, then divide this constant throughout the equation. So we will get like this. So here it will be x square by 4 minus y square by 5 is equal to 1. So this is the locus of the point. Locus of the point P. So I hope you all understood the concept that we discussed in this video. If you liked this video, please subscribe my channel and press the bell button for the notification. Thank you.